The way that I show you how to do PEMDAS, I need you to do it exactly the way that I show you to do it. And the reason why is because when we grade the final exam, if I can't follow what you're doing in the steps that you're supposed to be doing it, I can't give you partial credit. Whereas if you show me the steps, if you can at least tell me what to do first, what to do next, then I can start awarding partial credit. If you don't tell me what you're doing first, or give me any indication of what or how you're trying to do it, I can't figure out what it is you're trying to do, and I can't give you any points on it. So the first thing that you should do is simply substitute the value 3 for y wherever you see y. So all I'm going to do is rewrite it, substituting in the 3 wherever I see a y. And even with that, you have to be careful, because if you make a copying error along the way, like I almost just did, thank you, Tyler, then if you don't copy it right, you'll run into issues as well. Okay, what do you do first? Hunter.
The exponent on 3 over 2.
Okay, so you realize you have 3 sets of parentheses, and parentheses take priority. But within the parentheses, we have an exponent that takes priority over everything. So what you should do is you underline it with a single line. Do it this way. Now you've told me as your scorer, or if it's not me scoring it, your final exam, it could be another teacher from another building. You've told that teacher, I know that I've got to do 3 squared first. So automatically, just doing that, there's no way that you can get 0 points on this. You're going to get some credit. What's 3 squared?
9.
Watch what I do. Everything else gets copied exactly the way it was originally written, because I only want to do 1 step at a time. I will show you one opportunity where you could do more than one thing at a time, and it's coming up, but not yet. All right, now what? Yes. Look, the way you do it is PEMDAS, parentheses, exponents. Well, you have parentheses, but within the parentheses, this middle parentheses has got 2 things going on. You have a division and an exponent, so you have to do that first.
And I still got it right. So
It may still work out that you get lucky and it'll work out, but be careful because it may not sometimes.
well, I just did it when I got up to it. Like it was, and I just got up to it.
I know what you're saying. I understand. But if you want to stay true to the order of operations, you are doing that first. Okay? Sometimes you'll get lucky and you'll do something a little bit out of order and you may still get the right answer. I'm just telling you, do it this way. Now what you can do here is you can cheat a little bit. You have still 3 sets of parentheses, right? Yes? And inside the parentheses, you have 1 operation going on in each one. You have a division, and a division. Since they're all the same parentheses that take priority over everything, you can do all 3 sets of parentheses at the same time. You're allowed to do that. 3 divided by 1 is what?
3.
However, I still have not done anything with that exponent yet, so it's now 3 squared still. 18 divided by 9. 4 divided by 2.
2.
A lot less busy now. We're almost done. Kat, what gets done next?
Exponent.
Right. What do you get? Bring everything else down. Now what? I have seen people get this far, and then they get, when they do this, 14. And here's where you got to be careful. Because the hard part's done. Phil. You got to do 2 times 2. Remember, because multiplication takes priority over addition and subtraction. 9 and minus 4 is? And that's your answer, 5. Question number 2 I'm going to skip for now because there's 2 different versions out there. There's the Wind Rider version, and it's the version that you got, which is the cars and windows. Okay? Hold off on it for right now. I'm going to come back to it, but I got to snap it into Smartboard, and I don't have a copy of that particular question just yet. I will get to it, but probably tomorrow. So on that note, let's go to 3. Okay, here we go. What? No, not this time. I'm just going to go. PEMDAS, I always like to see, whenever I do PEMDAS, I want to hear all the different versions so I can get an idea of whether I need to spend time on it or not. This I know I need to spend time on because it's been a while since we've done it. Okay, you could do a couple things with this. Most students, if you see 6 and 3, count by 6s, count by 3s. And if you do that, it's going to work out exactly the way we want it to work out. Then count by 7s. Count by 4s. Okay. What was your different way? Because I'm not going to tell you whether you're right. If it may still be correct. What do you have? What do you have?
I did since 3 times 2 equals 6. I did 8, 4, 10 over 5. 3 times 3 equals 6.
You could do. No, he's right. He's looking at. Okay, he knows that the constant is multiplied by 2 when you go from water to orange or to flavoring. So that'll work for any number. If because there's in between ratios that are not listed here. So if you have a 4 to 8 is also going to work. So is 5 to 10. So is 7 to 14. So all of those in between ratios, as long as you understand it's in the ratio or the value of 2 to 1, which it is, there are other possible correct answers in that ratio table that you could use. If that confuses you, really the easiest way is just count by the number that you see. That determines your pattern.
Wait, would I get points for that?
I already explained. No, you won't. It's still correct because there's still equivalent ratios. That's what we've done. We've created equivalent ratios for 6 to 3. These are all equivalent ratios. There's other ones in between. There's a 4 to 8. There's a 5 to 10. They're all still equivalent ratios and they're still correct. What else did you get in there? What were your? Give me all your ratios. Read them off to me.
8 to 4, 10 to 5, and 12 to 6.
Yeah, all good. Because it's in the value of 2 to 1. So you're fine. This, however, a little bit harder to find the in-between ratios because then you wind up, if you do a 5 here, you're not going to get an even number up top. Okay? Because the value of this ratio, 7 to 4, technically, is 7 to 4. Even though you found unit rate this morning. We did unit rate. Okay. So now, honestly, when you get this particular question, and you will, there cannot be any points lost here. You've got to nail down this ratio table because if your ratios are wrong, everything else is wrong. Okay? So this is supposed to be the easy part of this question. Don't mess up your equivalent ratios. Make sure they're right. Okay, so now you can determine which has the stronger flavor. Here I will take a little vote. How many said orange? How many said cherry? All right, majority of you are correct. It's orange. Let's figure out why you went the other way. The explanation is more important than the actual flavor that you chose because you have to totally prove to whoever's scoring your final exam that you completely understand why it is orange. Who thinks they have a top-notch answer? Come on up because I'll mic you up.
I use different numbers though.
That's okay. Come on up. Let's hear it anyway.
Did I write it?
Well, first I want you to read it to me because you're going to be mic'd up. Here. You're good.
In the orange recipe, there's 8 tablespoons of orange flavoring and 4 cups of water. In the cherry recipe, there is 7 tablespoons of cherry flavoring and 4 cups of water. Therefore, the orange recipe is stronger because the more the flavoring and the less water makes the stronger taste.
All right, let me explain kind of what he did because essentially what he did is the same thing that you could still do. What he did, let's look back here, is he had that ratio of 8 to 4 here, which is still an equivalent ratio. Just let them be able to see too, okay? Let me see. Step off this up. It's all right. Hold on to this. Okay. So what he did, which in essence is what you have to do, is he said, okay, I have 4 cups of water with 8 tablespoons here. and 4 cups of water with 7 tablespoons. They have the same amount of water. So when you have an equal amount of water, when the water is being held constant at whatever value it is, the flavoring that has more tablespoons is going to taste stronger. So in this case, 8 is more tablespoons than 7, so the orange tastes stronger. Okay? If you use the ratios that are already here, and let's say you did count by 6s and count by 3s, and counted by 7s and counted by 4s, which set of ratios can you use to compare the water with? Nuts.
21 is 12 and 24 is 12.
Yes, you got this, and you got this. It's the same idea. You now have 12 cups of water being held constant. 24 is going to taste stronger than 21, and you need to explain that to get full credit. You can't just say that orange flavoring is going to be stronger because it has 24 tablespoons. You have to mention that the water is the same in both recipes, and when they're the same, it's the recipe that has more flavoring. So now I will write it down. Thank you.
You want this?
Oh, I want this.
All right.
And then go set. All right, write this down if you don't have it. So again, I'm just stressing to you that when you do this, you have to make mention not only about which has more flavoring, but that which has more flavoring when the water amounts are the same. So you got to mention water and flavoring to get full credit.
Wait, did I do that right?
Yeah, you had it. You mentioned the water. To me, your answer completely explains, and I know when I read it that you completely understand the concept. That's what your answer has to do to whoever's scoring it. There has to be complete understanding that you get the concept. So you got to mention something about the water and the flavoring. Do you have it? Can I go to the next question? Okay. All right, actually, I'm going to, let me put this on pause for a minute. So we're not taking time on the blog or in class to save a little bit more time. I had the points plotted already and showed you the best way to do this whenever you get, what shape is this, by the way? Trapezoid, the way it was taught is you want to break it up into 2 triangles. You can do it using composition, where you complete the entire rectangle and then subtract the 2 outside triangles. It'll work. It just takes more time. So when you break it up, you'll see a dotted line going across here. We have triangle 1 and triangle 2. And as long as you have a base and a height, you apply the formula. All right, triangle 1. You got to count the units because the base is the straight horizontal line going across. So if you count carefully, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, you get 17 units. I'll put it here. The answer is revealed at the bottom, but I'll just show it to you here for triangle 1, that the base is 17. And the height is from here all the way to point D, and that's 10. But don't forget, it's triangle, you have to divide by 2. What's the easy way to divide by 2? What can we knock out? Luke?
10, make it a 5, and a 2 or 1.
Yeah, and then you still do 17 times 5 off to the side, because 17 times 5, not everybody can do in their head. You get 85.
Yeah.
That's triangle 1. Here's 2. Another advantage when you break up a trapezoid into 2 triangles is that the height never changes. So I know that height's 10. But I've got to recount the base because the base is you can see it, it's less units. When you count it, it's 9. So now you have 9 times 10 divided by 2. Still split that 10 in half, and you can do 9 times 5 in your head to make 45. What do you have to do in the final phase? Add them together. And when you do that, you get 130 square units. Okay? Here it is all written out. Okay. Surface area, we just did it. Can I go around the room and just see the answer? Wait 1 sec, because we may be able to skip it. I need to go over it. How many unique faces are there in a rectangular prism?
3.
How many unique faces?
3.
Ben,
4, I should say.
how many unique faces in this rectangular prism?
With me?
Are you getting hung up on the word unique?
Yes.
How many? I just gave you the answer. There's three separate faces. Because each of those three faces have a parallel and congruent side. Uh-oh, I'm worrying. Look, that's a face. That's a face. That's a face. Altogether, there are 6 total faces, but 3 of them are all different. So this face 3 has a matching side on the other side. This one has another one underneath. And number 2 has one on the other side this way. It's a 3-dimensional object. Who could tell us what was the strategy that I taught to do surface area? Because it's not volume. If you did 9 times 2 times 3, that's not surface area. Andrew.
Do for number 2, 9 times 3.
Okay. Right, y times 2. Right, so there's a couple ways you can approach it. Find the area of these 3 faces. Add them up. And then do what, Andrew? Times 2. Or find the area of each face, multiply it by 2, and then add it up. Either way, you'll get the same answer. Let's just plug in our numbers. For rectangle 1, what was the base? Joe. What's the height? And if it helps you, put everything in so you can see it. Joe, what's the height? 9 by 2, he's right.
The height's 3.
We're doing number 1. 9, 2. 9 by 2, he's right. That's why I put that in there so you could see it. 9 by 2 for rectangle 1. I'm going to add it at the end and then multiply by 2 because I think it's easier. John, what's the base of rectangle 2? Still 9. What's the height? Yes. Total area, bud. That one's done. So, number 3, what's the base?
2.
Agree. What's the height?
3.
Total area?
6.
Okay. Now we got to add carefully. Remember, you don't have calculators, so you got to do this by hand. 7 plus 8 plus 6.
21.
2 plus 2 plus 1.
5.
Am I done?
No, you have to multiply by 6.
Yeah, I got to multiply by 2 because they have matching and congruent sides. You get 102. Do not forget your units. It's a point. Does? Okay. Feet squared. All right. We have modified this particular question, this type of question, that you can use any strategy. You don't have to use a tape diagram because I remember you didn't, right? But you may have forgotten how to do it. Well, I know a lot of kids did. I'm going to show it to you using a tape diagram. So I still think that works the best visually. Start off with the names of our 2 kids. What are they?
Billy and Ryan.
And no problem with you guys abbreviating their first names as long as they're different letters. I'm going to take the ratio that they gave us for Billy and Ryan, which is what?
7.
And put it in parentheses to the left of their initial. How many of you did do it using a tape diagram, or at least tried to? Okay, so make 7 boxes for Billy. Hopefully this will start to look familiar to you after you start to see it. Now, I don't know if you remember this or not, but there were 2 types of questions back in Mod 1 where you had tape diagrams like this. There were what was called a total question and a difference question. I don't know if you remember that. Like if they told you the difference between them was 55. This is a total question. So they're telling you that what's the total amount of baseballs that they hit? Say it. 99. That's telling you that all of these boxes have to add up to 99. Remember what I told you back in Mod 1. The objective is to try to find the magic number. You got to find the value of what each box is worth. How many total boxes are there? Total boxes. 11. 11 into 99 goes how many times?
9.
That's your magic number. Once you find the magic number, you add up all the 9s for Billy, or do 9 times 7. Add up all the 9s for Ryan, or 9 times 4, and you get your answer. 63 and 36.
I thought you used to do it.
When you did it as this. You did it, and it'll still work. 7 to 4.
Okay.
Total 11.
Oh, okay.
Okay? Difference is 3. If it's a question, then you've got to take whatever that difference is. Let's say it's 30, divide by 3, and you'll get the magic number being 10. It'll work, okay? But like I said, this is more visual, I think. What should 63 and 36 add up to as a check? It should add up to the total of 99, and it does. Okay, last question. The way that I taught this was using that little tiny template, but I'm going to show you a shortcut. Hopefully it's a shortcut. I don't know.
Is it the Matrix?
Do you remember the Matrix?
No.
I'll show you the Matrix too. Maybe you try to do it that way, but then there are other ways to do it.
Is it my way?
Yeah. Okay. First of all, you have to get the total of both items together, which is what? Come on, now you gotta know. Bib. Yeah, because the discount applies when you add it together. So this plus this is going to make 16,000, and that's the number that we got to work with. If you choose to use the matrix, you got to remember the matrix because it's not given to you. The matrix was, there was 2 columns. There was one for dollars and one for percent. I'm going to show it to you both ways. And then you had original price, discount. Sorry, hold on, I have it reversed. Discount, sale price, and original. And we did this. Let me move over this dollar sign a little bit too.
I remember that.
Yeah, remember this? I don't expect you to remember it, but it's been a while. Okay, if you could plug everything in, what you're really, in essence, is filling in, you're trying to find missing values of an equivalent ratio table. So now you got to decide what goes where. The $16,000 is what? Is it original, is it sale, or is it the discount? Right, I got to kind of squeeze it in there, but I will. Okay, that goes there. Now that 30%, when you have a percent, you always have 2/3 of a column. You'll see you'll have all three. Luke, do you remember?
Sale price less than 3%.
Be careful.
Oh, the discount.
It is the discount. This we technically don't have, but we have this. I don't know if you remember that or not, because the sale price is the price you pay. So this is actually what goes here. Right.
Yeah.
Okay. What do they want to know? Well, they want to know how much he will save after the discount. They initially want this, which you can do because you can make a love connection here. 100 times what makes 16,000?
16.
Be careful.
160.
160. Multiply by 160. Kat, we did this morning. 30 times 160. Yes. Now watch. I'm not even going to fill anything in yet, because if you can figure this out, the whole problem is done. That's what's great about the matrix. It takes care of everything. Doesn't take care of the last part about the change it gets back, but A and B will be taken care of. If you're going to multiply this by 160, you can use the same strategy and do 70 times 160. But you may have to do it off to the side. Can anybody do it? 70 times 160, because I can't do it in my head. Well, actually, I could, but I'm the teacher. Dill, what did you get?
11,200.
Money, yes. Okay, if you do the matrix, you have both answers for A and B. The price that you save is 4,800. The price that you pay at the register after the discount's taken off is 11,200. Marcus, you want to do it your way?
Yes.
All right. The shortcut, but I taught this to you a little bit, but a lot of you sometimes, I don't know, some of you just knew how to do it, I guess. I'm not quite sure, but we took the 16,000 and we multiplied by the decimal equivalent for 30%, which is what? 0.3 or 0.30. And you get that.
Take off the 0. Oh, wait, never.
I haven't moved my decimal yet. And that will work also. And then from there, okay, then you just said, okay, I'm saving this amount. I've got to deduct that from the original. And you subtract it and got this. You get full credit either way. Ben.
What? 60 times 70, I got 10,200.
Yeah, you have to carry a 1 somewhere. Right? 16,000, take away 4,800. Should be 11,200. You want to grab a calculator? You can. Just shoot. You did something, a borrow issue. Stop, please. Okay, so the last part now is, okay, he is got to pay 11,200, and he pays with 12 $1,000 bills, which is how much money?
Okay.
So you got to subtract it to figure out how much change he gets back. 800. Okay? All right, take out your agendas. I'm going to let you know what your homework is.